everyone. So this is lesson 3. Let me just scroll this down so we can see where we're at. We're lesson 3 in unit 3, part 1, radical expressions and equations. So we are starting on page 6 of your notes package. So the first thing here is a check-in. So just to kind of check in with what we've learned so far. So this is an opportunity for you guys to try this on your own, and then we'll go through it. So if you want, you're going to pause the video, try this first question, and then start the video again, and we'll go through it. So pause now. When you're done, we're back. All right, so we're back. So check-in question. In the diagram below, A, B, B, C, C, D, D, E, E, F, F, G, G, H, and H, K all have the side length of 4. So looking at this diagram, they want us to determine the perimeter of A, B, D, F, H, K. So it is this large picture where I've drawn the yellow glowy line. Now, from the information given there in that paragraph, this length, 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 and this length are all the same, and they're all equal to 4. And we assume that you can see where the right angles are labeled in. So we have right angle triangles forming these other hypotenuses that form part of our sides. So with that, because those are equivalent triangles, CBD or BCD, DEF, and FGH are all equivalent triangles, what that means is that this side here, and this side here are all equivalent. And we need those measurements because they're part of our perimeter that we're looking for. So we revisit our knowledge of right angle triangles and finding those out. We also have another side that we haven't analyzed here. And if we break it into 3 pieces, we know that this piece here is equal to 4. This is equal to 4. And the middle section is going to be equivalent to DF. So whatever our value we get for that side will go in that place. Now, what we don't know, we know all the sections that are 4s. So we know this is 4 and this is 4. It is just that other section, the double red score, that we need to solve for. So we're going to use our Pythagorean theorem to solve for that. So we'll look for BD. So we know from the Pythagorean theorem, BD squared is going to be equal to 4 squared plus 4 squared, because each of these sides is equal to 4. So to solve that, that means BD squared is equal to 16 plus 16, which is 32. So that means that BD is going to be equal to the square root of 32. And all I did for that was I took the square root of BD squared and the square root of 32. Okay, now because of our information up here, all of these are 4, and BD is going to be also equal to DF, and it's also equal to FH. Okay, and it also means that this part right in here is also root 32. Oops, why did I write root 35? Or we'll never know. So it's root 32. Okay, so let's think about what we have. We need to know then what AK is. AK is equal to 4 plus root 32 plus 4. Now, it's probably going to be a lot easier if we simplify that root 32. So root 32, if we simplify it, 32 is equal to 16 times 2. so I'm going to have 4 root 2. So that means when I simplify the expression for AK, it is going to be 8 plus 4 root 2. Okay, so now I have all my measurements. Now I can find out what my perimeter is. So perimeter is going to be equal to AB plus BD plus DF plus FH plus HK plus AK. Okay, another way you could do it, you could also say, well, I know I have 2 4s, the AB and the HK, but we can just lay it out like this. Okay, so AB is a 4, BD is a 4 root 2, DF is 4 root 2, FH is 4 root 2, HK is 4, and AK is 8 plus 4 root 2. So now we combine our like terms. So our perimeter, combining our like terms, we have 4 plus 8, which is 16. And I have 4 root 2 plus 4 root 2 plus 4 root 2 plus 4 root 2. So I have 16 root 2s. Okay, so that's our answer for perimeter. And you know me, put it in a box, give it to me as a present so I can find your answer. The next one wants to know the area of that triangle, or of that rectangle, ABHK. So that's just the big lower rectangle. So let's think about area is length times width. From that diagram, our length is equal to AB, which is equal to 4. And our width, we're going to say, is equal to AK, which is 8 plus 4 root 2. So putting that in the formula, length is 4, width is 8 plus 4 root 2. And again, it doesn't matter which one you use as length and which one you use as width. It's up to you. You're going to get the same answer. Now here we have to distribute. So that means we've got to multiply everything in the brackets by the 4 on the outside. And we're going to get 32 plus 16 root 2. And again, put that in a nice box and give it to me as a present. Okay. Now, when we're doing these multiplication operations with radicals, we have to recall multiplication, the multiplication property of radicals. So if we have the n root of AB, that is equivalent to the nth root of A times the nth root of B. So if I wanted to use an example using numbers, that would be that if I had the square root of 2 times 3, that is the same as the square root of 2 times the square root of 3. Similarly, if I had the square root of 4b, oops, I don't want to use a 4. If I have the square root of 7b, it's equal to the square root of 7 times the square root of b. Okay? Now, when we're doing our multiplication, we need to remember a lot of the strategies that we use when we multiply polynomials, and we can use those strategies in the same way to simplify and multiply radical expressions as we do with polynomial expressions. So the same strategies we use with perfect squares, difference of squares, and the distributive property are going to apply. Although the thing is, for radicals, you need to be aware of the radical multiplication property and any restrictions on variables, because remember, you can't have a negative under your radical. Okay, your radicand cannot be negative. So we're going to do some simplification using multiplication. Big thing to remember is it's coefficient times coefficient and radicand times radicand. And one of the common errors is people over multiply. They multiply many times, and you need to avoid doing that. So just keep that in mind. So here we're going to expand and simplify. Now looking at this first one, A, it's root 5 times 3 root 5 minus root 75 plus 3 root 3. Now before I multiply, because I like to deal with simpler and smaller numbers, what I'm going to do is I am going to change all the entire radicals, and there's only one in this case, to a mixed radical because it's going to make my life easier. So 3 root 5, leave that as is. Now root 75 is the same as root 25 times 3. So 25 is a perfect square, and square root of 25 is 5. So root 75 becomes 5 root 3. And then I have plus 3 root 3. Now again, if I want to simplify my life and before I multiply, I can do this, I can combine like terms. So I have my root 5 here, I have 3 root 5, and then I have negative 5 root 3 plus 3 root 3. So that is the same as negative 2 root 3. And now I just have to distribute. And when I distribute, I'm going to multiply everything in the brackets by that root 5. And when I do that, I get 3 times 5, because root 5 times root 5 is equal to 5. Plus, here I'm going to get, actually, it's going to be a negative. So I get minus 2 root 15. Now I'm not done because I got to multiply this 3 times 5, so 15 minus 2 root 15. And we'll just put that in a box so we can find that answer. Okay. Looking at the next one, and here you're really going to see why simplifying helps us a lot. We're going to go 2 root 11, 3 root 2. Now to simplify this, minus root 50. This would be minus 50 is 25 times 2, so 5 root 2. And then simplifying the 3 root 32. 32 is 16 times 2. So I can take a 4 out. So 4 times 12, or 4 times 3 is 12, so 12 root 2. Okay. Now they're all root 2's in the bracket, so I can simplify those first. So 3 minus 5 plus 12 is equal to 10 root 2. And now I'm multiplying coefficient times coefficient, radicand times radicand. So 2 times 10 is 20, and 11 times 2 is 22. And again, put that in a nice box so I can find it. Okay. But you can see in this one here that by simplifying those, by changing them to mixed radicals, I could collect them, and we could only have to do one multiplication. You would still get the same answer if you distributed first and then simplified, but I think doing it this way for this particular question makes it easier. Okay? Consider. So we're going to do a little expanding and simplify. Now, if we were given a polynomial expression that was, or multiplication that was multiplying 2 binomials, remember we talked earlier that we want to use some of the same strategies that we do in multiplying polynomials. What we would have to do is we would have to use FOIL or some other technique to multiply those binomials. So here we're doing the same thing except it's radical expressions. So we're going to use FOIL and we're going to multiply through. So multiplying first, 2 root 3 times 2 root 3, we're going to get 4 times 3 because root 3 times root 3 equals 3. Plus, doing our outer, 2 root 3 times 5 would be 10 root 3. And then our inner, negative 5 times 2 root 3 is negative 10 root 3. And then our last would be negative 5 times 5, which is negative 25. Now, just like when we do FOIL with polynomials, we're going to combine any like terms to simplify this further. 4 times 3 is 12. I've got 10 root 3 minus 10 root 3, so that becomes 0, and I'm left with minus 25. And then I can simplify that further, and that would be equal to negative 13. And again, let's put a little box so we know that that is the final answer. Okay, so we use FOIL, we collect like terms, and we simplify it to the simplest answer. And the next one, you'll notice that we have this little statement here because we have a variable in the radicand. We can't have a negative number, so x has to be greater than or equal to 0. Okay, we're going to do the same thing. We're going to use FOIL, and we're going to multiply and see what happens. So multiplying through, root x times root x is equal to x. Root x times 1 is equal to root x. Root x times negative 1 is equal to negative root x. And negative 1 times 1 is equal to negative 1. I'm going to combine my like terms. I've got root x minus root x, so that equals 0. So I'm left with x minus 1. That would be my answer. Now, the next question says, what do you notice? Well, you should notice with these that the middle term subtracts out. And it's very similar to difference of squares, which is Mrs. Finley's favorite binomial pairs. I don't know why. But if we look at those expressions, what we notice is that we have the same terms in each of them, except one is adding and one is subtracting. So one is adding and one is subtracting. But other than that, they're identical. So it's very similar to difference of squares. And what we get as our final answers, well, there's a little different here because, well, the first expression doesn't have variables in it, but the second one does. That is very similar in terms of that each of the terms is the square of the two terms in the original question. So let's take a look at what I'm saying. Given that the expression a plus b, given the expression a plus b, the conjugate is a minus b. If we have a radical expression, root a plus root b, its conjugate is root a minus root b. And when we multiply those conjugates, the result's very similar to what happens with the different squares, and it follows that same pattern. Okay? It follows the pattern with those things. So we can use that identification of pattern to help us, and we're going to do that on the next page, looking for that pattern with difference of squares. Okay? Simplifying expression with variables. Now, the first one, if I look at it, the first thing it says is identify the values of the variables for which each expression is defined, then expand and simplify. So looking at this, I have a variable in the radicand. So I need to tell me what values I can share. Okay, or I can use for a. So root a means that a must be greater than or equal to 0. So that's the values for a for which that expression is defined. Okay, so that's our first step. So we'll put a little box around that because that is part of what the question is asking. And the next thing we're going to do is we're going to expand and simplify. So we're going to use FOIL. So first, outer, inner, last. So doing my first multiplication, 3 times 4 is 12, and root a times root a is a. Second, the outer, root 3 times 5 is 15, and I'm left with root a. And inner, negative 2 times 4 is negative 8, and I'm left with my root a. And then finally, for my last, negative 2 times 5 is negative 10. Now, I need to combine my like terms. I have similar terms because I have 2 root a's there. So 12a plus, well, 15 root a minus 8 root a. I'm left with 7 root a. And I have my minus 10. Now, I have no more like terms, so that is my simplest form. Okay? So this next one here, we're going to identify the values of the variable. So x needs to be greater than or equal to 0, and y needs to be greater than or equal to 0 because they're both in the radicand and I can't have the negative there. So now I'm going to FOIL, but before I do, I want you to notice this is the conjugate of this. They're the same terms. The only thing different is one is negative or subtraction and one is an addition. So instead of doing FOIL, all I really need to do is square each of the terms. Okay, so I'm going to save myself a little bit of work there. So root x times root x is x, and then I know it's going to be separated by a negative sign. So 2 root y times 2 root y is 4y, and I am done. Now, if you're looking at them saying, I don't get it, just do FOIL. If FOIL works, and it will work for this question, that middle term, once you combine your like terms, will drop out because you'll get a plus a term and then a minus a term, and they'll be equivalent. But save yourself some work. Learn to identify those conjugate expressions because it's never a bad thing to find a little shortcut. Now, the next one, I'm going to have you guys do it. But before you start, I'm going to do one thing. First, I'm going to remind you to make sure you identify your values for your variables. But I want you to notice this is a square here. So you're going to have to expand this out. And then you're going to have to multiply. Now, these are not conjugates. It's a square. So you can't use the shortcut that we did before. My advice is to FOIL it first. So FOIL these first, and then once you FOIL, then you can distribute the two. So I'd like you to, in a moment, you're going to pause the recording, you're going to try it yourself, and then come back and see how you did. Okay, so pause now. And we're back. All right, so first thing we're going to do is we're going to FOIL this. So foiling through this first is going to give me 49 times x. Outer is going to give me minus 14 root xy. Inner is going to give me minus 14 root xy. And the last is going to give me plus 4y. Now I have to do my distribution. So I'm going to multiply everything by the 2. And when I do that, actually, you know what I'm going to do first before I distribute? Mrs. Finley, why'd you do that? I'm going to combine my like terms because I'd rather do one less multiplication. Okay, so 49x minus 28 root xy, because I have 14xy minus, I have minus 14xy and minus 14xy, and then plus 4y. And now I'm going to do my distribution. So again, I'm sorry about that. Sometimes I jump around. And when I multiply through, I get 98x minus 56x root xy plus 8y. Okay. Now, there's one other thing that we needed to do is we need to tell what our values for our variables can be. So x needs to be greater than or equal to 0, and y needs to be greater than or equal to 0, because in that original expression, they are by themselves in the radicand. Okay? All right, for D, hopefully that one went well for you guys. Again, looking at D, you can notice that they are conjugate expressions. So we're going to save ourselves some work. We're going to just basically square each term. So root x plus 1 times root x plus 1 is just x plus 1. And 1 times 1 is 1, and we subtract. So when I simplify this further, x plus 1 minus 1 would be x. So that would be our answer for that. And then a little trickier here in terms of the values for x, because I do have a variable under the radical, but there's this x plus 1. So that means that x plus 1 has to be greater than or equal to 0. So it's anything that is there underneath that radical that I have to make sure is not a negative number. So once I get this, then I can rearrange. It's just like solving an equation, except that instead of an equal sign, I have an inequality. So I want to get x by itself, so I'm going to move the -1 to the other side. So x would be greater than or equal to -1. So a little bit different there in terms of my value for my variable. All right, so looking at this, that's this multiplying radicals. So here is our assignment in your workbook. So it's extra practice on page 109. And again, if you have any problems, just